Might just introduce myself for those of you who don't know who I am. My name's Angela Gillam. I'm with Maritime Industry Australia Limited. We represent shipping interests in Australia. So we're up to session 10, and session 10 split into two parts, 10A and 10B. So our first speaker, despite what it says on the program, our first speaker is Dan McClary from Ramboll, speaking about ROVing around marinas. Thanks.
Morning, everyone. Sorry, Emily couldn't actually be here. She's been here for the first couple of days, but she's currently winging her way to Perth, where she's heading up to Exmouth and going to spend the next 10 days bobbing around off the northwest shelf in a small boat collecting samples of mud. So she's left this fun bit to me. Thankfully, she did the presentation for me, so I'll just speak to it. Well, so what we're going to be talking about is a program that we've run over the past 6 months or so, 10 months actually, for a local government authority in New Zealand. So we've been looking at using mini ROVs as a biofouling management tool. Okay, so we're using mini ROVs as a biofouling management tool. It's one tool in the toolbox that we have for biofouling management. So just briefly, a quick overview. So we're talking a little bit about the piece of equipment that we're going to be using, the actual project itself, and vessel hull surveillance, and a brief assessment of, how well has this thing actually worked? What's its utility? Is it actually efficient? And then a little bit of information on, final thoughts. So here's the beast itself. We're using the Blue Robotics Blue Rov 2. It's a small unit. It's probably sort of this big. It's really not big at all, but really quite powerful. This picks up in one sense from a presentation that Ashley Coots gave a couple of years ago. I think it was at this conference when he compared different types of mini ROVs. And one of his recommendations, or one of his findings, is that this is one of the better ones. So we spent some time looking into it and found that, it really does provide a lot of bang for the buck, really. It's surprising how good it is for the relatively cheap price. So again, the technical specs itself, the key bits to think about, though, are the fact that it's got 6 thrusters, which gives us a lot of attitudinal control of the vessel. It's also quite powerful. It can maintain station in speeds of up to 2 knots, 2 knots of water speed, so that's really quite great. Really good lighting systems. We put on extra lights. It's got 4 sets of lights on it. Live high-definition video feed to the surface, so the operator can really get a good indication, a good picture of what's happening. Works up to 100 meters depth, and we were really working sort of surface down to about 3 to 5 meters overall. Nice thing is that the software is open source, so it's continually being updated at relatively low expense, which is nice. And it's got a very good autopilot system, so it's basically push button and it will hold station for you, even against currents, which is quite nice. Of course, when you are holding station like that, it uses a lot more battery power, so we try not to do that too much. Again, it's quite small, less than 10 kilograms in weight, so it's very easy to move around, and reasonable battery life, so we're getting 4 to 6 hours overall. Again, depending on what the currents were doing and whether or not we had to do a lot of station holding. So the project itself, again, we were working in the Auckland region looking at a vessel hull surveillance program. So the Auckland Council has been looking at vessels for the past couple of years. They've used exclusively divers previously, and this year they said they'd give it a shot of doing a hybrid sort of diver and ROV combined approach to see how well we can actually detect pests. So really what they want to get is an indication of the general state of biofouling on small vessels, generally less than 25 meters, commercial and recreational vessels in the Auckland region, just to see what's actually happening down there. We were focused in marinas and mooring areas primarily, and also in some anchorages. So we set it up so that the ROV was being used predominantly in the marinas, entirely in the marinas, and the divers, free-swimming divers, were working off in the mooring areas or the anchorages. The key piece of information that we're getting out of this, aside from sort of digital imagery, was that we're getting a level of fouling information. Everybody's familiar with the level of fouling scale, I'm assuming, and also using the U.S. Navy's fouling rating system. So we just wanted to get an indication of what's on the bottom, and are there any specific invasive species or known invasive species like Mediterranean fanworm, different ascidians, crabs, that sort of thing. In the Auckland region, there's thousands of small boats. It's a boater. It really is a boater's paradise. I'm one of them, so I've got a monohull sailboat as well. But there's a lot of different types of boats. There's not all just one type, and as a consequence of that, you've got to be prepared to look at a variety of different shapes underwater. You've got multi-hulls, monohulls. You've got boats that have bow thrusters, boats that don't. So initially, we'd set up sort of a search pattern where we'd start at the stern and then work along the keel and towards the bow, and then come back and sort of meander around as we were looking at the different types of appendages that were on the boat. Generally speaking, that search pattern was a great idea, but it really came down to the type of boat. I mean, you've got some sailboats which have a very, very deep keel and a bulb in the bottom, so you've got to spend some more time on that. So basically the idea is you've got to actually, this is a broad indication of the search patterns we were using, but they would change depending on the individual boat that was looked at. This is the region that we were actually working in. So from Whangateo Harbour in the far north of the Auckland region. We're also looking at Sandspit. There's a marina and an anchorage, or a mooring area in there. Kauau's an anchorage and moorings. Maharanga is moorings in there. Gulf Harbour is one of the bigger marinas. And then there's a whole series of marinas down in the central part of the city. This is Whangateo Harbour up in the north, tidally dominated, so we had a very short period of time in which we could actually do the work itself. So the divers had to get in, get the inspections done fairly quickly and move out. So each of the red dots is a position of where we did some of the inspections. So there's 22 in total in there. These are the two larger marinas. So Gulf Harbour Marina on the left, there's 1,100 boats in that one. West Haven Marina on the right is, I think it's about 2,000-ish boats. So there's a lot of boats in a small area. We allocated the vessel targets in each marina in proportion to the total berth fleet. So if there's let's just say that there are 10,000 boats in berth in the Auckland region and 10% of them were in West Haven, then we would allocate proportionally to West Haven or Gulf Harbour, wherever it was. So in these two marinas, we're looking at about sort of 3,000-ish boats. So we managed to survey approximately 200 in those two marinas. And just some of the things we're also doing, again, as I said, we're looking at the divers. So the divers were up there, they jumped in the water, take a look and see what they could see. Dive operations generally are restricted by good environmental conditions. So if the environmental conditions deteriorate rapidly, they've got to get out of there. So that was one of the limitations for us. Here's a quick video of dive survey. Now again, one of the first things that we had to do is look at the level of fouling on the vessel. Some boats were easy to sort out. Some boats were a little bit trickier. This was possibly one of the easier ones. There's a fair bit on that. I don't think that boat's moved in a long time. And we were also, again, using the blue ROV. So quite easy to use, but we were also seeing some fairly heavily fouled vessels as well. So you can see the propeller, the nice folding propeller on the center bottom there. That's not turned for a while, and I think there'd be some serious problems if they tried to turn it now. And likewise, a little bit of video from the ROV glider, for one thing. This particular boat was actually a level of fouling 5. It was pretty clean in the stern towards this area, but as you moved more towards the forward ends, it was pretty messy overall. Okay, so how well did this piece actually work? Again, you can see at fairly small, lightweight, you basically have a very sophisticated controlling system. That's an Xbox controller that's used, just plugged into a computer. It works extremely well. It's extremely easy to use. It's really quick to actually learn how to use it too. We put the team with one of these ROVs in a pool basically for half a day. And within a half a day, you can really control it quite well. Sure, the first few inspections we actually did in water, it took a little bit longer because you're getting used to how it works and how you can actually control it. But quite rapidly, we were able to get up to speed. It's a very useful little tool. So if we look at it, what are the pluses and minuses? Well, again, small size, low weight, really easy to learn and use. Let's get a big tick from us from there. Again, it's portable, so you get rapid mobilization. It takes a fairly small team to actually work with it. It also provides really good video imagery. So that's going right into your computer. You just push the button and it's all collected instantly. So if you need to go back, reassess some of the level of fouling scores you've done, it's really easy to do. So big ticks there. Another big tick, again, only needs 2 people. So easy to move between sites. When we were working, we would predominantly work, say, an individual marina. We'd go to a particular pier, set up the equipment, which would probably take 15 minutes to be fair. And then from there, we would work on the nearest 8 vessels. So very easy to move up. You do the 8 vessels and break it all down and move to the next spot. You're able to move through it fairly quickly. Big ticks. Good resolution on flat hulls, no question. But the issue are niche areas, and that's always the issue, whether or not you're dealing with an ROV or you're dealing with divers. Getting into those niche areas, looking into them, looking around those corners, that's kind of tough. So that's a bit of a downside. Again, divers will be experiencing the same thing. Also, downside is that you are influenced by currents, and particularly by passing vessels. So one of the marinas we were working in, there was an active ferry service. So the ferry would go by every 15 minutes, and they weren't going by slow. They were going by fairly quickly. So there was a lot of wake in the marina, and the boat would be or the ROV would be getting pushed around. And suddenly, you're on the boat beside, and not where you're actually planning on being. There's also, and this is the biggest tick down, is that there is a real potential to dislodge samples. So we've noticed that particularly if during wake events when a boat would go by, we'd be brushed up against the hull. So that would cause some potential dislodging of biofouling. Also, even just pulling away from a boat quite quickly, the thrust from the actual thrusters would actually wipe some material off, but fairly loosely adhered stuff. And there's still a question mark about how well this is actually going to be useful in open water. So when we're actually not standing on a marina jetty, but actually in a small boat bobbing up and down. I have used them before in small boats, and it does work. It takes longer. And in that case, divers may actually be a better tool to use. And we also haven't done any testing on vessels larger than 25 meters with this particular ROV. I've done inspections with larger ROVs on big ships, but it's quite a different kettle of fish. Right, well, how well did it actually work overall? Pretty well. So in 9 marinas, we did 400 inspections. 32 vessels per day was our maximum. And we were working towards the end of the season. So we were working sort of March, April. So the daylight hours that we had, the daylight duration was actually much lower than it would be, say, if we started in early summer. So we'd actually started late due to some contracting issues. So we got those 400 inspections done in 16 days. We're thinking this year when we start off, which will probably be in sort of mid-December, we'll probably knock them off in 10 days, easily. On the other hand, if you look at the diving side of it, so 27 vessels per day was their maximum. Again, they've got a lot more moving back and forth between the different locations. So it took them a little bit longer to do the inspections. They did 14 different mooring sites around the Auckland region, plus 1 marina. There's a marina up in the upper Waitemata Harbour, which is very tidally dominated. The visibility tends to be not so good. So we thought at the outset, I think we'll actually put the divers in here because it's going to be, the visibility just won't be there for the ROV. So I think that's a limitation on the ROV. However, it turned out the visibility was good. So we're going to put the ROV up there this year when we start it again in December. All right, so some final thoughts on the utility of this beast. Well, the pros, rapid deployment by a small team, and that's really good. So if we were to find out that there's a vessel that needs to be inspected, it's fairly small, we can get on site quite quickly. So that's quite handy. Another is that the machine is actually quite inexpensive, less than $10,000 US, and you've got a very capable unit. It's also easily repairable. We looked at a number of different units, the deep trekker, we looked at the video rays, which are also small mini ROVs. Those particular ones, say for the deep trekker, if anything went wrong with it, it would have to go back to the manufacturer. And that's a pain because they're in North America. Whereas the blue ROV was very easy to swap out parts. So if we lost a thruster, we could take the thruster off and put a new one on. If we needed new lights, we could do the same thing. Really, really quite flexible. It was actually shipped to us in pieces, so it was a kit set, effectively. A little bit of IKEA ROVing. So you pull it together and you got a box of parts and an instruction manual which is poorly written and somehow make it happen, and we did, and we've all got 10 thumbs, but still we made it happen. So very easily repairable machine, really cost effective for small jobs. So if you just need to go out and look at one or two vessels, you can do it quite rapidly. Other nice thing is get that automatic video recording, high definition video, so you can go back and look at things. That station keeping is fantastic. So in those instances when a vessel would go by and we'd have some wake, it would actually hold its station quite nicely. And the downside is that if it was a big boat and there was a big wake, then nothing's going to hold against it. I guess you'd say that could be an issue with divers as well. Dislodging pests is a problem. Collection of samples is a nuisance because you can't. And also viewing inside the niche areas is a problem. Before we start off the sampling in December coming up, we're going to be doing some upgrades to it. We've added a grabber, so we're going to be able to actually collect some limited samples. You can also put additional cameras on it. So we've got some GoPro mounts which we can put onto the frame, and then we can be collecting still images at the same time. There's also a Blue ROV heavy option which provides for additional thrusters, and that will give us a lot more attitudinal control over it. Currently it's really good going forward, backwards, up, down, side to side, but if we need to look at something up there, it's a little bit tricky because the camera only sort of rotates through a few degrees. So we'd have to go back and look up, and it's not that great. With the heavy option, we'll be able to rotate the machine so we can look up like that, which is much better. So we'll get that underway before the next season. And the overall assessment is that while it does have limitations, no question, divers have limitations, it is a useful piece of kit for the inspection toolbox. Thank you.